So this is the second recording on a series about fluids and thermodynamics in the use of RefProp and Igor Pro for the study of such fluids and thermodynamics. So I have again reloaded RefProp and loaded Igor, and this is the file we started last time in the last video. Now what I have done is I have created two directories in the root folder of Igor, one for ethane, which contains the data that we worked with on the last video, and one for benzene, which, as I had mentioned, does not have all of the phase boundary data in RefProp, but I'm going to show you how to work with it to create some of the phase boundary information, even when you don't have the full phase boundary information. Now, one of the things that we ran into last time was we couldn't find the triple point density of ethane. And this time I did succeed in finding the triple point density of ethane, 544 kilograms per meter cubed. That is 0.55, that's 0.544 grams per milliliter. That's the conversion factor when you're doing that. And 0.54 grams per milliliter is the equivalent of 18.091 moles per liter, which is reasonable. And so I'm going to go ahead and add that to the ethane data. So that would be in the triple point. So that would be, the melting would be the good place to put that. So at 97.368, sorry, not 97.368, wrong space to put that, delete point, do it, adjust this just slightly. So just like I have a 2 points here, I have 2 points here. So at 90.368, the pressure is still 1.421 E to the minus 5. And I'm just going to put this density in the density liquid of melting, because it's not really worth putting it in the density of the solid, because I don't really have a solid. And here in the sublimation, I'm going to do the same thing. So 90.368, the sublimation pressure is 1.1421 E to the minus 5. And the, it goes down. And the liquid density is 18.091. So that'll finalize those phase boundaries in the graph. And you can now see I have that phase boundary that goes all the way over to here. And that's the gas solid phase boundary. And if I were to zoom up really, really close and at really, really, really low pressures, I would see that's down there. And I think I will leave the sublimation and the solid at a, what color do I want? Let's put them in brown. A good solid color. So that was this was ethane. And to make sure I can keep track of different data sets, I'm going to control Y, or window control. I'm going to change the name of this to ethane phase diagram, because that way I can keep track of the phase diagram. And I'm going to also control Y, again, window control, change the window name of this table to ethane phase data. That way I can keep track of the table, because now in Windows, if I look in graphs and tables, I will see the ethane phase data, ethane phase diagram, and that'll allow me to keep that separate from the benzene phase boundary and the benzene phase diagram that I'm about to do. So now I've got benzene already loaded in RefProp, and I did not set all of that up to do, but I do need to write down all of the information. So I'll do that real quick. So the triple points, 278.7. Kelvin, don't have the triple temperature. Critical point is 562. Errors in my book. Okay, so to get the initial phase boundary, we already know for saturation tables, I don't have solid, liquid, or solid vapor. So initially, I'm going to just start with vapor liquid. And that would be starting from the triple point, 278.67, going to the critical point, 562.02, and I'll initially step by, say, 2. That gives me a series of points. Do I have to step that fine? Probably not. Does it kill me? Step by step. Try that again. Saturation table. Okay. Step that by 5. That's our start. We can always add to it. Okay. That gives me a starting point, starting set of data, which again in E4, create a table and paste. And again, create the names. So this is T vapor, P vapor, density of liquid for the, I think I did put vaporization density, vapor for vaporization. Okay, I named that thing. Oh, saturation, that works too. So to keep the names the same here, change these to sat. That way everything is consistent. Okay. So, and just like I did for ethane in that longer video, I'm going to display the vapor pressure versus the density liquid saturation, and then append to graph the vapor pressure versus the density vapor saturation to get my starting curve. So that's the starting curve. And just like before, we have that big gap at the top, and now I'm going to step into that gap. My critical temperature was 562, and you can see I don't have a 562. So now I'm going to go to calculate saturation points at equilibrium, and now I'm going to create a series of temperatures above 558 going towards 562. So 559, 560, 561, and because 562 is the critical point, now I'm going to step more finely, 561.1, 561.2, 561.3, 561.4, 561.5, 561.6, 561.7, 568. Could you use that same stuff as before? Yes, you could. And then 562.02. So now I will take these, I will copy them, and I will paste them into Igor. And now I've filled out my phase boundary. And again, I'm going to do the same thing I did for the ethane plot. I'm going to make this, because it is a phase boundary representing when I transition from single phase to two phase, I'm going to make that a thicker line. Now, that gives me the first of my phase boundaries. I cannot get the melting line. We know the sublimation line is probably going to be really, really small. So that one we'll go ahead and ignore. And we know it's going to be really, really small because the pressure at the triple point, 278.67, so the triple point pressure is 0.0478 bar. I'm going to go ahead and write that down, 0.0478 bar. And the liquid density at the triple point is 11.445 mole per liter, and the vapor density is 0.0020715 mole per liter. So that gives us the density of the liquid and the vapor. It doesn't give us the density of the solid. That one I was also able to Google, and it was 11.253. So how do we go now and get the melting line? Well, we know that this fluid is okay in terms of the equation of state to the melting line. So what I will now do is I will go to specify state point, and I will just type in my temperature, 278.67. That's my triple point temperature. Now my triple point pressure is, we just saw that, 0.047836, and that gives me the liquid density at the triple point. Now, we know that the maximum density that the equation of state is good to is 11.45. So I'm going to just see if it'll calculate 11.5. And you can see it's going to give me one or more points out of what range do I wish to continue the calculation. If I hit yes, it doesn't calculate. So that means it's not going to go past that. I hit yes to 11 point, it's not going to go past that either. So 11.45. And that means the maximum pressure I can get in terms of my phase diagram is that. So that's about 5.5. So now what I'll do is I have two choices to make. I can either put that on or I could see. Okay, so that means in order to get more than 2 points here, step the pressure up to 5. 2, 7, 8, 6, 7. 2, 7, 8, 7. 2, 7, 8, 7. 7, 8. And then 2, 7, 8, 7, 5. It's going to give me that error because I'm above max density. Won't calculate. So now 278.67, and I'll put the max density at 11.5. And you can see 5.48. And you can see the density is not changing all that much. So now if I copy these and I put in here, and I go ahead and add to it the 278.67, the density of the triple point solid 253, which I looked up in Wikipedia. So yes, that means that benzene solid is slightly less dense than benzene's liquid. I will now be able to at least do the approximate of the melting line, which give me this is T underscore melt. This is T underscore melt, and this is the liquid melting line. And again, I'll pin melt, liquid melt. And that's it. That's all we got for the melting line. And that's because we get to the place where the density maximizes and ref prop calculate past that. You can see the density is barely changing. So if I really wanted to extend that line in Igor, I can eventually just hand draw a dashed line to show by eye this is the direction that that melting line would most likely go. And we might do that a little bit later. So this would be what you can get of the benzene phase diagram. You will notice that what we don't have is the sublimation line, which would extend this down, but it's already close enough to 0 that we don't really have to worry uber a lot about the sublimation line. And that's true for a lot of systems, is the sublimation line is not really something to panic about because it's usually so small. The one fluid, the only time you really need to worry about sublimation line is if the triple point pressure is like 1 bar or higher. So that if the triple point pressure is less than 100 millibar, the sublimation line is pretty much not going to be in a range where you have to worry about it too much. As the triple point pressure increases above 100 millibar, 0.1 bar, then you're going to begin to be able to see a gap here, and you're going to need to start being concerned about it. I might do CO2 as an example for that in another video. So that, again, is just showing you how to use RefProp to get a melting line predominantly when you don't actually have the data for a melting line.